Okay, this is the second half of your test review, Chapter 8 material, which was all of our system stuff. This part of the test, these problems that you're about to see, are what will be on Friday's part of the test. So again, you can use a graphing calculator on this if you want to, but you must show all your work algebraically, especially a problem like this one where you're graphing. Show how you do it by hand to be able to receive the full credit on the problem. So here we need to graph. We can either graph one of two ways for these. You can graph by finding x and y intercepts and then plotting those and connecting them, or you can get the equation in slope-intercept form. If I have an equation in standard form like this, I prefer to do the intercepts, so I'm going to do that. If I want to find an x-intercept, I let y equal 0. If I let y equal 0 in this top equation, I'll be left with 2x equals 16, and therefore x equals 8. So I have an x-intercept point on the x-axis at 8. If I want to find a y-intercept, we let x equal 0, which would give me negative 3y equals 16. And that means y equals negative 16 thirds, which for graphing purposes we could say is negative 5.3 repeating. So negative 5 and then a little bit is where we are on my y-axis. And from there we can connect our lines, our points, and make our line. There we go. Okay, for the one at the bottom, again, I'll find an x-intercept and a y-intercept and use those to graph my line, but you could easily get the y alone and use slope and y-intercept. If I let y equal 0, I'm just left with x equals 7. Nothing to solve for. To find my y-intercept, if I let x equal 0, I have negative y left equals 7. So y equals negative 7. Graphing, I'm going to make a point on my y-axis at negative 7, a point on my x-axis at positive 7, and then from there, that's not super straight. Let's see if I can make that a little bit better. There is my line. You can always use a straight edge if you want another piece of paper or something to make those lines as straight as you can. Now remember, graphing isn't perfect. It's not very accurate, so there's going to be a range of answers that will be accepted here. You're looking for approximately where these points are touching. So I'm going to say approximately 5, negative 2 would be a solution there, but again, there's a little room for error because of the lines. You can see mine, sometimes not super straight. So if you had, for example, an x value that was, between 4 and 6, and a y value between negative 1 and negative 3, you'd probably receive full credit for this problem. Okay, the next problem, number 12 for our test, you are solving algebraically, and it doesn't specify here to solve the system using substitution or elimination, so you can choose how you want to do that. If it's me, I personally prefer elimination if I can use it. In this set of problems, I could multiply the top by 2 to get my y's to cancel, so that's what I'm going to do. That gives me a 4x, a 2y, equals 6, and then I can add my equations together. Make sure you have opposites here so variable cancels. That's going to give me 7x equal to 14, and then I can divide both sides by 7, and I get x equals 2. Once you have one of those answers, you can plug it back into either original equation. I'm going to use the top equation. 2 times 2 plus y equals 3. 4 plus y equals 3. And then subtract 4 to the other side. I'm going to get y equals negative 1. You can write your answer on your answer line as x equals 2, y equals negative 1, or you can write it as a coordinate to negative 1. If you want to check it, you can graph both of these in your calculator and look for that intersection point, or you can plug 2 and negative 1 into both equations and make sure it works in both equations. Number 13 is, again, a solving problem. I know the question came up a lot when we were working on the quiz about an easier way to do this problem. The method that we used in the notes was to do a quick substitution at the beginning. So make sure you're writing this out if you choose to do the problem this way. You're going to say let u, or you can use any other variable you want, equal 1 over x, and v equal 1 over y. So if we think of 5 over x as 5 times 1 over x, I can rewrite this top equation as 5u. Instead of 10 over y, I can rewrite it as 10 times 1 over y, or 10v, equals 3. And the bottom equation will be similar. It'll look like 2u minus 12v equals negative 2. From there, you can solve using either substitution or elimination. I'm going to use elimination again. I'm going to multiply my top equation by negative 2 and my bottom equation by 5 to get my u's to cancel. That's going to give me a negative 10u minus 20v equals negative 6. And on the bottom, I'll have a 10u minus 60v equals negative 10. Add my equations together, the u's cancel. I have negative 80v equals negative 16. And then to solve for v, I'm going to divide both sides by 80. So I'm going to have 16 over 80, which reduces to positive 1/5. Once you have that, you can plug it back into either original equation with the u's and v's to solve for u. I'm going to plug it in here in the top. So 5u, I don't know that, plus 10 times v is 1/5 equals 3. So 5u plus, if I multiply those, I get 2 equals 3. 5u equals 1, and therefore u is also 1/5. Now you need to remember at the end of this, you are not solving for u and v, you're solving for x and y. So we want to go back then, and once we know v is equal to 1/5, we can say 1 over y is equal to 1/5. And then hopefully you can see that y equals 5. If you had a set of numbers here that it wasn't as obvious, you could always cross multiply to solve. And then the same thing's going to happen instead of u. I put x back in. And you can see x is also 5. So the final answer is x equals 5, y equals 5, or the coordinate 5, 5, which you can plug back into the original set of equations and make sure that works in both. The next problem, number 14, it says, write a system of equations to represent this situation. A chef makes $17 more per hour than her assistant chef. Their combined earnings in a 40-hour week are $1,880. What is the hourly rate of each? We are not solving here, although you could if you want to check to make sure your answers are reasonable so your equations are good. All you have to do on this problem on the test is write the system of equations. So the first thing you're going to have to do are say what your variables represent. So I'm going to say let C equal the hourly wage of the chef. Is one thing I'm solving for. And let A equal the hourly wage of the assistant. You don't have to use C and A. You could use X and Y or whatever variables you choose. I just like to use letters that make it easy to distinguish which is which. So the first sentence we had of information was the chef makes $17 more per hour than her assistant chef. So that means the chef's hourly wage equals her assistant's wage plus an additional $17. Another way to write this equation is you could say C minus 17 equals A. Just the same equation, but the 17 moved on the other side. Now, when you have a system, two variables means you need to write two equations. The next sentence says their combined earnings for a 40-hour week are $1,880. So that means if the chef works for 40 hours and the assistant works for 40 hours, they make a total of $1,880. And there's my second equation. And again, that's all you're going to have to do for this problem on the test. If you wanted to, if you had some extra time, you could go back and solve this and make sure you get reasonable answers. If you got something like the chef makes negative $3 an hour, obviously, you know, something's wrong with your equations and you want to go back and check it and maybe edit some things to make sure that your equations give you some reasonable solutions. But you only have to write the equations. And of course, to write the equations, you'll also have to define what your variables are. Number 15, this problem, we are solving a 3x3 system. Remember, in these problems, there's a lot going on, so you probably want to keep it organized. I'm going to number my equations 1, 2, and 3. The next thing I have to decide is what variable I want to get rid of. It looks like the y's or the x's aren't too bad. I'm going to use my y's to eliminate here. So to eliminate my y's, I'm going to pair up equation 1 and 3 to start. And again, because I want to get rid of my y's, I'm going to multiply the bottom equation by 2. So that would give me 6x plus 2y plus 4z equals 10. If I add those equations together, I'm going to get 10x, my y's cancel, 7z, and 11. And that new equation with 2 variables, I'm going to call equation number 4. We're going to repeat the process again, pair up 2 more original equations, but you have to get rid of the y again. So this time I'm going to pair up equation 2 and 3. And to get rid of the y's, I think I'm going to multiply the bottom equation by -3. So that would give me a -9x, -3y, a -6z, and a -15. Add my equations together. I get -8x, y's cancel, -10z, and a -22. I'm going to call that equation 5. After these first 2 steps, you should have 2 equations that have the same 2 variables. If that is not the case after these first 2 steps, you need to go back and change something because you're going to get stuck. So I'm going to write down equation 4 and 5 together here. And now I want to solve this 2x2 system using either substitution or elimination. Again, I'm going to use elimination here. I'm going to multiply the top by 8 and the bottom by 10 to get rid of my x's. So that's going to give me 80x plus 56z equals 88, -80x minus 100z equals -220. X's cancel. I'm going to have a -34z, and then -220 and 88 are going to give me a -132. To solve for z, I'm going to divide through a -34, and I get 66 over 17 when I reduce that fraction. Okay, that number looks a little weird. Let's see here. Oh, let's see what I did. That should have been a -44. Sorry about that, guys. That's what I get for doing math in my head. And then -132 divided by a -44 gives me z is 3. Okay, that's a nice pretty number. Not that a fraction is bad, but I just wanted to make sure before we went too far with that. All right, once I know z is 3, I can plug that back into either equation 4 or 5. I'm going to use equation number 4. 10x plus 7 times 3 equals 11. So 10x plus 21 equals 11. Subtract 21, that gives me -10. And that means x equals -1. And then if I go to any of the original equations, I can solve for y. Let's say I go to equation number 3, because the y is already alone there. 3 times -1 plus y plus 2 times z, 2 times 3 equals 5. So that's -3 plus y plus 6 equals 5. And to get the y alone, I'll subtract 6 and add 3 to the other side. So 5 minus 6 plus 3 gives me y is 2. Final answer, you can write x equals -1, y equals 2, z is 3, or you can write the 3-dimensional point, -1, 2, and 3. If you want to check it, type all 3 of those numbers into all 3 equations and make sure you get true statements for each. The last problem on the review is a system of non-linear equations. You can use either elimination or substitution for these problems, but remember one is usually easier than the other. In this problem, because we don't have any like terms between the first equation and the second equation, substitution is the best. And I'm going to isolate the x in the bottom equation. So that would give me 4 minus 2y. And then we're going to plug that in for x in the top equation. Make sure you put it in parentheses when you plug it in. 4 minus 2y quantity squared plus 4y squared equals 16. Make sure you FOIL anytime you have two terms with a plus or minus between them and then squared. If you need to write out FOIL in both parentheses twice, do that. First terms here are going to give you 16. My outside terms are negative 8y, and my inside terms will also be negative 8y. Together I'll have a negative 16y. And my last terms, negative 2y and negative 2y, give me a 4y squared. Bring everything else down. From there, I can combine my like terms. 4y squared and 4y squared give me an 8y squared. Minus 16y, and then actually I have a 16 on both sides, so when I subtract that over, they're just going to cancel and give me a 0. From here, you can either divide everything by 8. Let's go ahead and do that. Usually we like, if we have a quadratic, for it to be equal to 0 with nothing in front of the squared term. So if I divide everything by 8, I get y squared minus 2y equals still a 0 over there. And because this is not a trinomial, 3 terms, you can just factor out what the two terms have in common. These two terms have a y in common. And if I divide that out, it leaves me with y minus 2. If I set both of those factors equal to 0, I will get solutions for y of y equals 0 and y equals 2. You need to plug both of those back into either of the original equations. I'm going to use the bottom equation because it's linear. So if I let y equal 0 in that bottom equation, I'll just have x equals 4 because the 2y term disappears. If I let y equal 2 in that bottom equation, I'll have x plus 2 times 2 equals 4. So x plus 4 equals 4, therefore x is 0. So you have 2 points of solutions. On the answer line on the test, you should write these ones as points because we have multiple x's and y's going on, so you want to distinguish which pairs go together. My first solution is 4, 0, and my second solution is 0, 2. If you wanted to check those, you can plug both sets of points into the equations and make sure they work. On this portion of the test on Friday, there will also be a bonus problem, and no, I will not tell you what that bonus problem is.